Let's see now how we can summarize data coming from a variable at a higher level. Actually, we're going to only start doing that because we'll go into much more details in the future. So we're going to look at the situation where our variable has an order. So more specifically, we're going to think of our variable as an ordinal variable. And so we're just going to focus on the fact that its values have a natural order, even though what we're going to say can be applied to numerical variables. That means interval and ratio level as well. Now, first of all, notice that everything we've done with nominal variables can still be done here. We still have values, and therefore we can figure out how many times the value has occurred, so obtaining its frequency, or the proportion of times, the percentage of times, and we can even figure out what the mode is. Okay? So all of these things can be done. For instance, the table that we saw earlier can be reinterpreted if we think of the values a, b, c as low, medium, and high. Now we're not dealing with the nominal variable anymore, but with an ordinal one. And we can still talk about medium being the mode because it's the most frequently occurring one. We can talk about low having a frequency of 16 and a percentage of 32. Notice that in this table I'm denoting the total sample size with capital N. That's a very good and acceptable alternative. So either lowercase n or uppercase n will do. But in this situation, we can actually do more. We can do more than simply computing these basic summaries, because we can use the natural order of the values to get some more information and some more summaries. For instance, let's have a look at this bigger table. So let's say our variable has possible values 0, 1, 2, 3, 4, 5. Remember, however, we're still assuming this to be an ordinal variable only. So 0, 1, 2, 3, 4, 5 is to emphasize the order. They may not be actual numbers. They may be extremely low, very low, low, medium, high, and very high, or something like that. So I'm going to use those just for convenience. Okay. So first of all, we can compute the mode of this data set, and we can see that the mode will be the value 3 because it's the one that happened most often. 23 times, that's more than any one of the other values. But we can do more. We can look at the minimum. In this case, the minimum value we actually observed is 1. 0 was a possible value, but we never saw it. And therefore, the minimum in this particular data set is 1. We can also correspondingly look at the maximum. Of course, in this case, 5 was the highest possible level that we could see, and we did see it 11 times. And therefore, 5 is the maximum. And then we can put the minimum and the maximum together, and that's usually called the range. Now, keep in mind there is another interpretation of the word range that we're going to see for numerical variables, but remember, these are not real numbers that we're dealing with. So all we can do is put them together, and in this case, therefore, the range would be 1 to 5. But there is more that we can do. What we can do is we can look at the median. Now, what is that? I'm going to have to give you some technical definitions here. So, the median is the value so that at least half of the data are less than or equal to the median, and at least half of the data are greater than or equal to the median. If you're confused by now, don't be surprised. This is a messy technical definition. It has a more, and by the way, that definition is done to take care of possible ties, because the median could end up being a little bit of a problem if we define it as being just a half below and half above, exactly, because of possible ties. So, the key idea is still that what we want to do is we want to pick a value that divides the data set into two parts as equal sized as possible. So in this particular situation, for instance, I claim that the median is going to be the value 3. Why is that? Okay, look at the frequencies values. We are right here with the number 3. If we count how many times we saw values equal to 3 or less, we end up with 23 plus 7 is 30 plus 4 is 34, and that's more than half of the 65, right? The 65, half of that will be 32. And similarly, if we count the numbers from the number of times that we saw 3 or more, we also get 23, 43, 50, 54. Well, that's a lot. Still, it's higher than, it's more than half of the sample. And therefore, that's why we pick the numbers 3 as the median. Okay? This may create a little bit of confusion at times, but hopefully with practice it will become a lot clearer. Now, from the median, we can go on and define some more similar kind of summaries as we're going to do in the next video.